Hi guys, so today I'll be explaining the Chemistry Week 11 AMS quiz. And it's really easy, there's some past material and just a few stuff you need to memorize. Okay, so which of the following are diprotic acids? Diprotic acids are acids that react to give away 2 protons to other atoms. Okay, so you only need to know these two, the sulfuric acid and I don't know what this one's called. And which of the following is a net ionic of a neutralization reaction? Neutralization reactions, you get that when you have an acid and a base. Because when acids and base react, they make a neutral product, okay? And we know acid like H plus, base OH minus, okay? So let's just check. HCl and water. HCl acid, water is neutral. That's wrong, because again, neutralization reaction is acid and base, right? Fe metal, HCl acid. That's wrong, again, because we need an acid and a base. Ca metal, Cl, not sure. So anyways, metal, wrong. NaCl base, H2O neutral, wrong. H plus acid, OH minus base, so it's correct. And also H2O is neutral, so it's correct. Neutral. Okay, which of the following could be used to prepare soluble salts? Okay, I'm just gonna write like a really quick table about what you need to know for like the AMS. So we have salts. We have 2 types of salts. We have either soluble or insoluble, صح? Insoluble. So insoluble salts we can prepare it only using precipitation, which is by mixing 2 soluble salts. Okay, now soluble salts you can make them using 2 ways, either titration, which is by adding an acid and a base, and then you get salt and water, or you can use excess method. By the way, titration only works with Na plus, K plus, and H4, and like basically alkali, the alkali group. You know it in the periodic table. I'll show you one sec. So anyways, excess method, we have like 4 ways, A, B, C, D. So metal and acid, which release a salt and H2 or H plus and whatever hydrogen. Metal, oxide and acid, which release salt and water. And then metal, hydroxide and acid, which release salt and water. And then metal carbonate and acid, which release salt, water, and carbon dioxide. It releases carbon dioxide because carbonate and acid when they react, they release carbon dioxide. Okay, so these you need to know them, and I'll show you the alkali group. By the way, take a screenshot because you're probably gonna need this, or if you have it in your notes, please just revise. By the way, this is the group, yeah? It's alkali. Okay, again. So, the action of an acid upon a basic metal oxide. Yep. Because again, you remember the first one, in the excess method. No, not the first one, wait. Acid and metal oxide. You can use that to make a soluble salt. It's one of the excess methods. Acid and a metal, yep. Base upon carbonate, no. acid upon carbonate. Acid upon bases, yep, for titration. And then base and sulfate, no. We never mentioned sulfate. Okay? Okay, an aqueous solution of hydrochloric acid is added to lumps of calcium carbonate. So, acid, or HCl, acid, and CaCO3. Now, which one of these react with an acid? You know, carbonate whenever it reacts with an acid, we get carbon dioxide, right? So we're gonna get bubbles, bubbles of gas, which would be carbon dioxide. And then what are the products of net ionic equation of the reaction? So again, CaCO3 and HCl. So HCl acid and CaCO3 calcium carbonate. We know that whenever a metal carbonate and an acid react from the excess method, we know that we're gonna get salt and water and carbon dioxide. The salt would be in, out. We get CaCl, then H2O, and then CO2. So CaCl and H2O and CO2. Which one of these are in the options? Not this one. Water, carbon dioxide, and that's it. So it's these two. Ammonia is produced industrially from nitrogen gas, hydrogen gas, and hydrogen gas, a process called the Haber process. So again, Haber process, it uses a temperature of 450 degrees Celsius and pressure of 200 atm, which if you convert that to pascals would be a times 100, so 20,123 kilopascals. Okay, and we know that the catalyst is finely divided iron. Okay, so 200 and 450 degrees Celsius, catalyst iron, and a catalyst increases the rate of the reaction and it has no effect on the yield of ammonia, because again, catalysts, they lower the activation energy, making the reaction faster by finding a new path, and they have no effect on the yield. And no matter how much more catalyst you add, you're not going to get more ammonia, you're just going to get the reaction in a faster rate. Sulfuric acid is manufactured industrially by the contact process. After reacting molten sulfur with air in a large furnace, the sulfur dioxide SO2 produced is mixed with more air to produce A under certain conditions of temperature and pressure. We know that temperature is always 450 degrees Celsius, and pressure for the contact process is 2 atm, which is 200 kilopascals. Okay, and product A would be SO3, product B would be H2S2O7, and yeah, that's all you need to know. Okay, so product A is SO3, and then we know that pressure is 200 kilopascals or 2 atm for 100 degrees Celsius, and the catalyst is vanadium pentoxide. This is the Roman number for 5, or V2O5. That's just the chemical formula for vanadium pentoxide. Okay, so select the weak acids. We know that strong acids are HCl, HBr, HI, H2SO4, and HNO3. And the strong bases, strong base, are LiOH, NaOH, CaOH, 2, BaOH2. Okay, so if we want to find the weak acids, they're not going to be on the strong acids table, right? So, okay, HCl, it's a strong acid here, so wrong. NaOH, it's a base, so wrong. CH3COOH, that's a weak acid. H2SO3, that's a weak acid. H2S, that's a weak acid. And HNO3, it's here, so it's a strong acid. So it's these three. 1, 2, 3. Strong bases, let me just write the table again. Okay, so HNO3, you know, that was a strong acid. H2SO3, that's a weak base, no? Weak acid, sorry, weak acid. KOH, that's a strong base. Oh yeah, that's a strong base, so that's correct. HCl acid, NaOH, strong base. So it's these two. Identify, okay. So remember from last week we had acid, base, amphoteric, and neutral. So acid is non-metal, and oxide and oxygen or whatever, and base would be metal, oxide, amphoteric. You have to memorize them. Neutral, you have to memorize them. So acid would be any like CO2, base, MgO, amphoteric Al2O3, PbO, ZnO, neutral CO, NO, N2O, H2O. Okay? Acid react with base react with acid, amphoteric reacts with both, neutral reacts with none. So let's check the question. MgO, we know Mg is metal oxide basic. C is non-metal, so non-metal and oxygen acidic. Cu, copper oxygen would be basic. N2O neutral, CO neutral, ZnO amphoteric, SO2 acid, Al2O3 amphoteric, Ca is as a metal and oxygen basic. Okay, so we know that 7 is neutral. Any number higher than 7 is basic. Any number lower than 7 is acidic. Okay? So A would be acidic, B would be neutral, C would be basic, and D would be basic. Okay? So A acidic, B neutral, C and D are basic. A student is asked to find the OH of the hydrochloric acid aqueous solution whose pH is 5.36 at 25 degrees Celsius. Calculate the concentration of OH minus. Okay, so we know that we have 3 steps. First step would be finding if we have OH or H or both. Here in HCl we have H. And then second step, finding the number of OH or H's we have. Here we only have one HCl. And then the third step would be multiplying the number by the concentration that they gave us. So they didn't give us a concentration, they actually gave us the pH. So how can we find the concentration of H plus using the pH? So we know, okay, pH is equal to 5.360, and we know that negative log of H plus is equal to pH, right? So if the pH is equal to 5.36 and you multiply both sides by negative, so log of H plus is equal to 5.36. Sorry, negative 5.36. Okay, and you know that whenever we have log, it's like 10 to the power of whatever, right? So we're going to do 10 to the power of negative 5.36. Or, wait, they want three significant figures in scientific notation. So 4.37 times 10 to the power of negative 6. That would be the concentration of H plus. Wait, what? H plus. Now here they want the concentration of OH minus. You can just use the KW formula, which is equal to the concentration of H plus times the concentration of OH minus. So 10 to the power of negative 14 is equal to 4.36 times 10 to the power of negative 6. Or wait, it would be more like accurate if you use the whole number that you get on the calculator. So if you're using your calculator, write answer times x. No. Do 10 to the power of negative 14 divided by the answer, because we're going to put the h plus to the other side, so we're going to divide by h plus. Okay, so we're going to get 2.29 times 10 to the power of negative 9. That would be the concentration of H plus. OH minus. Sorry. Okay? So 2.29 times 10 to the power of... Well, what happened? Okay. Negative 9. And now a student wants to find the concentration of H plus ions and OH ions in a sample of 0.4 molarity of a strong acid, H2A, aqueous solution at 298 Kelvin. Okay, so we're gonna follow the steps. First step, find out if you have H plus or OH minus or both. Here we have H plus. Second step, find the number. Here we have 2. And then third step would multiply the number by the concentration. So 2 times 0.4, we get 0.8 molarity, and that would be the concentration of H plus. Okay? So here they want scientific notation. 8.0 times 10 to the power of negative 1. 8.0 times 10 to the power of negative 1. And then they want the concentration of OH minus. We're going to use the KW formula. So 10 to the power of negative 14 is equal to 0.8 times x, OH minus. Put that to the other side to get 10 to the power of negative 14 over 0.8. And then you get 1.25 times 10 to the power of negative 14. So 1.25 times 10 to the power of negative 14. Okay, and then here they want you to calculate the concentration of H plus ions in a 0.6 molarity aqueous solution of KOH at 25 degrees Celsius. So we're going to follow the steps again. First, you're going to find if you have OH minus, H plus, or both. Here we have OH. Second step, find the number. Here you only have 1. Third step, multiply the number by the concentration. So 1 times 0.06. That would be the concentration of OH minus. Here they want the concentration of H plus. So we're just going to use the KW formula. 10 to the power of negative 14 is equal to 0.06 times concentration of H plus. I'm going to put the 0.06 to the other side, so 0.06. We're going to get 1.66666 times 10 to the power of negative 13. Here they wanted two to two significant figures, so we're just gonna round it. So 1.7 times 10 to the power of negative 13. 1.7 times 10 to the power of negative 13. Okay, a student is asked to find the pH of a solution in an experiment. He prepares an aqueous solution of a hydrochloric acid by dissolving 0.08 moles, hydrochloric acid HCl, 0.08 moles of the acid into 150 milliliters of volumetric flask filled up to the calibration mark at 25 degrees Celsius. So here they want us to find the concentration of H plus, and they gave us the moles and the volume. So we're just going to use this triangle, and the volume has to be in decimeter cubed, so we're going to divide by 1000, so 0.25 decimeters cubed, so 0.08 over 0.25, get 0.32, and since they want three significant figures, we're just going to add a 0, so 0.320. Then deduce the pH of the solution. We know that the pH is equal to negative log of concentration of H plus, and if you have a box here, just put 10. Okay, so here the best method to obtain ZnSO4 as a solid, so ZnSO4, when H2SO4 reacts with ZnO is, okay, look, so we know we're going to use in and out, so in, ZnSO4, out, H2O. So if I have ZnSO4 and H2O, how do I get rid of the H2O? We just use crystallization, right? So crystallization, that's the answer. Crystallization. A mixture of NH4NO3 and NaOH solution are heated. A gas with a pungent smell is released. Okay, so NH4NO3 and NaOH. Which one of these react with NaOH to release a pungent smelling gas? NH4, right? We know it's NH4 because they didn't add aluminum powder. If they added aluminum powder, which is the catalyst, then we'd know it's NO3. But no, it's NH4. Why? Because they only heated it. They didn't add any aluminum powder. NH4 and the NaOH reacted to release NH3, which is the pungent smelling gas, which turns wet red litmus paper blue. Okay? So red litmus paper blue, and the gas produced is ammonia. To prepare PbSO4, equal quantities of... Okay, so first we're going to check if it's soluble or insoluble, so we know which method we need to use to prepare it. We know SO4 is always soluble except when it comes with Ba, Ca, and Pb, and here it's with Pb, so it's insoluble. So we know that insoluble salts can be prepared using precipitation, which is by mixing two soluble salts. So we're gonna need to use Pb and PbOH. OH is always insoluble except when it comes with any of the salts from the first row in the periodic table, so that's wrong. NO3 is correct, and PbCl, that's wrong. So PbNO3, and we need a salt that ends with SO4 because we're gonna go in and out. So SO4, and SO4 is always soluble except when it comes with Pb and Ba and Ca, so it's not the last option. And SrSO4. I don't know what that is. So anyways, you know, Na is from the first row, and whatever comes with the first row is always soluble. So we're gonna use PbNO3 and NaSO4, and let's just check. If we go in and out, we're gonna get PbSO4 and NaNO3. Is that what they wanted? Yep. So we're gonna use the precipitation reaction. Okay, because both salts need to be soluble and we're preparing an insoluble salt. When a strong acid and a strong base react in quantities that contain equal number of moles of H plus and OH minus, a neutral solution is produced. A neutral salt could be prepared by mixing a strong base with a strong acid. A solution is made by adding sulfur trioxide to water. The pH changes from, okay, so we know water is neutral, so it's gonna go from 7 to acidic, so 1. When what solution is added to what, CO2 is produced? We know that CO2 is produced when CO3 minus and acid react. So carbonate and acid, or acid and carbonate, same thing. When what solution is added to what, the mixture is heated, SO2 gas is evolved. We know SO2 is produced whenever SO3 minus and acid react. So acid and SO3 sulfide. Okay, here when what solution is added to what and the mixture is heated, NH3 gas is evolved. Here they said heated only, they didn't add aluminum powder, so it's gonna be NH4 and NaOH. So which one of these has, okay, first OH, so KOH and NH4, KOH and NH4. Bismillah. Okay, thank you guys for watching. I hope you guys understood, and good luck on your exams.